Helical Spring. A helical spring is a wire coiled in the form of a helix whose function is to distort when loaded and to recover its original shape when the load is removed. Here, we are using this helical spring to find the force constant of the spring by plotting a graph between load and extension. Theory. The helical spring works under the principle of Hooke's law, which states that within the limit of elasticity, the strain produced is directly proportional to the stress applied. When load F is suspended from the lower free end of the spring hanging from a rigid support, it increases the spring's length by amount L. Then, according to Hooke's law, F is proportional to L, or F is equal to KL, where K is the constant of proportionality called the force constant or the spring constant of the spring. But F is equal to mg, where m is the mass producing an extension of L. That is, the spring constant K is equal to mg by L. Materials required: spring with a fine pointer, a rigid support, a weight hanger of 50 grams slotted weights, 50 grams slotted weights, a vertical wooden base. Procedure. The spring with fine pointer is suspended from a rigid support. Attach a weight hanger for 50 grams slotted weights from its lower end, which will act as dead load. Set the vertical wooden scale such that the tip of the pointer comes to the divisions on the scale but does not touch the scale. With the weight hanger alone attached to the spring, the reading of the pointer on the scale is noted. Slotted weights are added one by one to the weight hanger, each time noting the scale readings. Now, slotted weights are unloaded one by one, and each time the reading of the pointer is noted. Repeat the process till only the hanger is left. The mean of readings X corresponding to loading and unloading for each load M is calculated, and the corresponding extension L is determined by finding X minus X0, where X0 is the mean reading obtained from zero load or dead load. The spring constant is calculated using the formula K is equal to mg by L. A graph is plotted with load mg along x-axis and extension L along the y-axis. A straight line graph is obtained. From the reciprocal of the slope of the graph, the spring constant K is calculated. That is, K is equal to AC by BC. Applications. The helical spring is the most commonly used mechanical spring designed to carry, pull or push loads. Helical springs are also used in engine starters and hinges.